It's working. Good evening, ladies and gentlemen. It's my pleasure to welcome you here in the Prague House on yet another edition of the Science Café. On this occasion, together with our distinguished guests, Mr. Ondřej Adamovský from the Resetox Center, which is the part of the Faculty of Science of the Masaryk University in Brno, and Mr. Guillaume Corradino, the director of the Pint of Science Festival. It's a very convenient name, by the way. Today, in this occasion, we will explore or elaborate on the microplastics and their impacts in our everyday life. And I would like to use this opportunity as well to thank the organizers of this event, which are the Czech Center in Brussels, and the CELO, Czech Liaison Office for Education and Research in Brussels, the South Moravian Region Representation Office in Brussels, and the Prague House. Ladies and gentlemen, excuse me, please enjoy your evening. Thank you.
Thank you very much for the introduction, and thank you very much for inviting me to moderate this event with Ondřej. So I'm the director of Pint of Science Belgium, just Belgium, but Pint of Science is located in 29 countries, so I have a lot of friends all around the world. As for my name, close enough, it's Guillaume, but if you don't have the inspiration to pronounce it properly, you can just call me Orange or whatever you want to call it. I've been called many names before. So before I introduce Ondřej a bit more, I will do a bit of housekeeping. So how is tonight going to take place? So first of all, the event is streamed online on Facebook, so I hope your partners know where you are and they will not find out on Facebook. If you don't want to be filmed, get in touch with one of the organizers and they will put you in a corner, I suppose, so everybody will be safe. So, program for the evening. We will start with about 40-minute conversation with Ondřej, where he will tell us about his work and microplastics and what it means for us to understand what microplastics are, what they do to us, to the environment. And after 40 minutes, we will give you the floor, so you will be able to ask questions. And after that, you will be welcome to a glass of wine. But you need to earn the wine, so please prepare your questions. If there are no questions, there is no wine. Okay? At least 3 questions from the audience, otherwise no wine for anybody. So please be ready. Now, I think we're ready to go. So, you have been already introduced, so I will just complete by saying that indeed you work at the Institute of the Faculty of Science of Masaryk University in Brno. Your research focuses on environmental toxicology, meaning that you aim to understand the mechanism and impacts of exposures to chemicals and toxins. And we had a little chat before to understand whether pesticides were toxins or chemicals. They are chemicals, now I know. And we're not going to talk about pesticides today, just microplastic, and I think that's more than enough to create anxiety for us for the evening. Ondřej has been involved in various Horizon 2020 projects in the past, so the European research program. And he works as an expert evaluator for European Research Council, and he's a guest editor for several journals. So he knows what he's talking about, and I'm not going to contradict him on anything he's going to say tonight. If you want to contradict him, you do it at your own risk after the conversation, okay? So first of all, Ondřej, am I forgetting anything about you that has not been mentioned before when introducing you?
No, thank you for the introduction. It was quite complete. Thank you.
That's almost too easy. So, on my side, I'm going to start with a simple question. So I assume microplastics or very small plastics. But I'm not an expert. So why don't you tell us exactly what we are talking about here?
Yes, correct. So the microplastic is the topic of this evening. As you may know, the microplastics really come from the bigger plastic. So if the bigger plastic in the environment degrade in time, the microplastics are created. And they are ubiquitous in the environment currently. we actually recognize two sources of microplastics. One, degradation products of bigger plastics, most probably waste. And the other one are so-called primary microplastics, and we made them. We made them, or our activities made them. And we made them for various purposes. For example, in cosmetics, as those ingredients that actually can get rid of your dead skin. I think peeling agents, it's called. And I don't use it, of course. But the other sources are, or the other applications are, like, for example, for drill liquids, or for paints as fillers and stuff like that. So we make them. And if we make them, then sooner or later end up in the environment. That's one part. The other part is those particles that really are created by degradation of bigger plastics, by abrasion or by chemical degradation, by biotic degradation, but they stay in the environment, and that's become a problem.
All right. In a nutshell, why should we care?
That's a good question. I mean, we should care. Because the plastics, they are everywhere. They sooner or later end up in the environment. And we have to say that the plastics, they are pretty stable. They stay in the environment for decades, for years, for hundreds of years. Even from the Middle Age, when the center of Brussels was created, if somebody would leave a piece of plastic there, we would still find it and we would be able to use it, because the degradation is so slow. And most of the plastic, we have to realize, was created to stay long, but they degrade in time very slow. But the amount of plastic that we produced in the past is enormous. From 50s, when the plastics was actually invented and massively used and massively manufactured, we use more than 9 billion tons of plastics. That's a lot. Currently, we making as a whole world, we are making like 800 million tons per year. And the annual growth is 8%. So we are making more and more plastics. Even the recycle rate is quite high. It's like about 3% in Europe. Still, many of the plastics then end up in the waste, and sooner or later then become in the environment.
But,
yeah.
I mean, okay, I understand microplastic, the volumes, it's huge. But are all microplastics equal, or should we be worried about some kinds of microplastic and not the others? Are we including the so-called bioplastics in there, or not?
Yeah, that's a good question. Maybe a little bit back from basically I did not answer your question why we should care. We have to follow the precaution principle, that we have to investigate and understand what is the problem about, to really be prepared when the problem will come in a massive way. It's a good question. Microplastics is a general term. It's something like pesticides. There are a lot of chemically different pesticides for many purposes. The microplastics is the same. So we recognize a lot of microplastics that actually originated from different plastics. PVC, polyethylene, polypropylene, many different plastics. And also they differ in shape, in sizes, in a chemical composition, because the plastic is a very complex product. It's a very complex mixture of chemicals. So when we are talking about microplastics, we should not mention microplastics as a group, but each problem is connected with a specific size, which is very important in terms of, for example, the biological activity, form, size, and the origin. The bioplastics, that's a good question. I'm back. The biopolymers, yes, they can create small fragments called microplastics, but the biopolymers, that's also a general term. We as customers are always confused. What does it mean? The biopolymers can actually mean two things. The polymers, they can easily degrade in the environment, so they don't stay long, or they are made out of the biological materials like sugar-rich plants, crops, and stuff like that. So, and yes, they can create microplastics, but they, in terms of the biodegradable, they fastly degrade. Polylactic acid, for example, the bags are made of polylactic acid nowadays, or some of them, if you reach the proper store. So
is it safe to say that they are good, or at least not so bad
it's definitely not what we want in the environment, and this is not what we want in the food chain for many reasons. As I said, the increase of plastics, the increase of microplastics create a problem for various reasons. For example, nowadays, we can find microplastics almost everywhere. There are studies that found the microplastics in the Arctic regions, in the high icebergs in the Alps. You can find them in aquatic and marine biota, in soils, in the deepest place on Earth, in the water. You can find them almost everywhere. And most importantly, you don't find them in the environment, but in the biota as well. So, for example, if you like have a time to go through the scientific literature, there is many evidences that microplastics and nanoplastics, that maybe we will talk about it a bit later, can be found in many organisms from shells, fish, plants, higher aquatic animals, in almost every meal that we eat, or in most importantly in biota, it's bad for them. So it's a problem.
So how likely is it that I'm carrying microplastic in the body and that we're all having microplastics? I mean, are we talking about everybody is contaminated, or should we not panic yet?
No, there is no time to panic. No, definitely not. Okay. There are actually two questions. In biota, yes, there are many studies that clearly show that whatever you sample, you can find the microparticles there. It's part of the dust, so it's almost everywhere in waters, in beers, in salt and stuff like that.
Did you say beers?
I said beers. Yeah.
Oh.
It's yeah, but in case of beer, it's a question of cost and benefit, right? But yeah. In terms of humans, of course, that even the environment is that's definitely what we should take care in terms of the quantity of microplastics, because the environment is heavily contaminated. But in terms of humans, they are estimation how we humans are contaminated. It's because we can't really sample humans. That's what is not allowed. So we have indications. For example, somebody calculated based on the data and based what we eat, that every of us can ingest 50,000 particles of microplastics a year, which doesn't mean it's harmful, because other studies say that based on the rodents, we are able to ingest or the particles that are in our body, in our digestive system, can actually cross the digestion blood barrier like in only 1%. So it means that you can intake 2 particles a day, which is considered as not a harmful level for us. So far, I mean, the indications are that some smaller fraction of microplastics can go inside our body, specifically the particles that are lower than 10 micrometers. It's very small fragments. And then we have nothing about the fate. What is happening to us? We don't know that. We don't have the informations. So
just to go back a second, because you talked about particles in the body. Particles, to me, doesn't really, I can't visualize that. How does it translate into tablespoons of plastic in the body?
Okay.
Are we talking less?
Teaspoon? Yeah, it's a good question. It's a very tiny amount, but you have to consider that microplastics, we are talking about micrometers. I know that many of them have no idea how much is a micrometer, but let's say that your human cell is 50 micrometers, and we are talking about the particles that are 10 times smaller, that is the size of your cell. So 50,000 of those particles is definitely not a teaspoon. It's less than that. More is way less. Okay,
don't get angry, but I checked Wikipedia before this event, and I read that the size to be considered microplastic is 5 millimeters. Does it make any sense to you as the expert?
Yes, that's correct.
Because I would definitely notice if I were to...
That's correct. The microplastics, they have their own definition, and the definition says that every plastic piece that is less than 5 millimeters can be considered as a microplastics, because 5 millimeters is 500. Every single plastics below 5 millimeters can be considered as microplastics. But a bigger plastic is not that big problem for us as for the biota. The lower you go, the bigger problem it is, because the lower fraction below 10 micrometers can actually, cross the barriers in your body and can actually reach up the organs. So that would be something that we should be worried about, I would guess.
Okay, so smaller is not better in that case.
Definitely not.
Definitely not. Right. Okay. So the challenge, you say we can't sample our bodies to find out how much we have. So how do you do? How do people detect? What are the techniques to detect in the biological world the amounts or the traces of microplastics?
Yeah, good question. First of all the studies that are done with microplastics are actually done on experimental animals, and we know that they are able to once they are ingested, they are able to migrate. So then we can the results extrapolate on humans somehow. The detection techniques, that's a real challenge, because nowadays we have 3 different techniques how to detect microplastics in the environment. The bigger particles are completely okay; they are detectable. You may observe them under microscope. That's not a big problem. But the problem is below 5 to 10 micrometers and to nanoscale. Currently, even if we have techniques such as Raman spectroscopy or Fourier transformation infrared spectroscopy or other fancy names for different techniques, they are not able to detect particles that are, for example, lower than 1 micrometer. And many of the particles that are lower fraction. So it's complicated to detect them. We know they exist, but it's complicated not only detect them, but to study them, to say something about the risks that are connected with those particles with regards our, for example, human health. So yeah, that the detection is a real problem nowadays.
Well, I assume that this is where you come in with your research.
Sort of. I'm a toxicologist, so what we study not only like how the microplastic, what the microplastic can do with your body or with some model organism, but we actually study the chemicals that are inside. So that's what my job. But I'm happy that I cooperate with my colleagues from Czech Central European Institute of Technology, specifically with Professor Kai's group, on a novel detection system that would be able to somehow visualize small particles in an intact organ. That's what we are working on. The methodology itself is based on computed tomography, very sensitive computed tomography. There are many advantages. For example, the recent study showed that it's an Italian study that showed that we can find microplastics, microparticles, 10, 15 micrometers polystyrene, I think it was, in placenta. And now it's a big question: how is it possible? Like for me, because these particles are pretty big, and I know that microplastics are everywhere, and there is a high chance for cross-contamination. Basically, you can find microplastics almost everywhere, and it's very difficult to bring some specific piece of organ, cut it, bring it to the laboratory and study the microplastics, because the microplastics are everywhere. So the methodology that we are actually doing is able to see the microplastics in the organ without any cutting. So the chance for cross-contamination is very limited. So if we would optimize and bring this methodology, we believe that we can really bring a very solid proof that the microplastics can be found in human body, which, by the way, is very questionable nowadays, because the techniques that are using does not directly prove of microplastics in the human body.
So you're saying that there is a chance that after drinking a few beers that I don't actually ingest and keep the microplastic in the body?
I see that the beer is something that that is value.
I'm also worried about the wine.
But yes, that's correct. The presence of microplastics is currently, I would bet, almost everywhere, including beers.
All right, so we can't escape it. So the food chain is contaminated, according to you, according to science.
Yeah, basically, it's very difficult to get rid of the microplastics, and the reason is, if I mention the aquatic biota, the shrimps, the shells, the fish, of course they are exposed in the environment where they live. But those plastics that are, for example, in the food, they come from packaging. That's the thing. They come from packaging. and through the how you process the food during manufacturing.
Okay.
There are, for example, studies that show that if you have a plastic bottle and you open it and close it a couple of times, you increase the number of microplastics there, which is completely understandable.
I was about specifically to ask about plastic bottle. So if you just open it once, the fact that it's in a plastic bottle, do you get the microplastic in the water? If you leave your bottle outside,
that's
maybe
what
in the sun?
That's what the study says. Yes.
Okay.
But again, you have there are different. They are
going to
like,
spend a nice evening, I think.
But again, if you have the microplastics in your digestive tract, it is considered that the level of contamination of microplastics in your digestive system is not that high to reach harmful levels so far.
So far as the science knows.
So far as the science knows, and so far in the current situation. But the problem with plastic is increasing. We are producing more and more plastics, and the plastics that more and more erode in the environment. So we consider, or we think, that the problem will be much higher in the future. That's why it's important to study them now, and that's the answer for your question why we should care.
Indeed, and this is what you do as a toxicologist. You're looking at what type of chemicals specifically from the microplastic get into the body, right? How long they stay, what they do?
Yes, that's another question. So the microplastics, they can do something. For example, if you see the rodent study or the mice study, it shows that the microplastic inside your body can cause an inflammation. Or when you inhale them, you have like asthma-like symptoms. So there are specific endpoints, specific adverse health outcomes that are connected with microplastics. But you have to take into account that the microplastics come from the plastics. And the plastics is a complex mixture of chemicals. Now we have here a wooden floor, but in the hotel where I live, they have a PVC floor. And the PVC is a plastic that is full of additives. Right? Many of the plastics are full of additives, but in PVC, 60% of weight of a PVC plastic is not a plastic. It's a chemical called phthalates. Because PVC is very hard material, so make it flexible. You have to put there a lot of chemicals. And they are just plasticizers. But the plastics itself, they have a lot of chemicals they can leach, and this is what we study as a toxicologist. Make the long story short, every single plastic is different. Every single plastic has their own combination of very wide variety of chemicals. They are plasticizers, they are colorants, they are UV stabilizers to be stable in UV light or in sunlight, antioxidative agents, sleepers, for example, tables, right? Anti-fog agents. They for example, if you have a salad in the supermarket, the plastic, it has antifogs because everybody would like to, buy the salad that looks nice. Processing agents, a lot of them. And it creates a very unique mixture. So the microplastics, when they are inside your body or inside the animal's body, the biota, the fish, they can release those chemicals they are harmful for the metabolism, they are harmful for the immune system, and they are harmful for microbiome living in those organisms. And that's important. This is what we study and this is what we found.
Could you give maybe a concrete example of the consequences of this?
Okay.
For the
so
body?
Specifically, the research where I was involved, and that was by the way part of a Marie Curie sponsored by European Commission. That we investigated a specific plasticizers. The plasticizers are probably chemicals that are in every single plastics and microplastics, and we found that once they are ingested, they can not only release the chemicals, but the chemicals itself, they can deregulate immunity, metabolism, and the microbiome in the way that the microbiome send the signals. They are deregulated. They send the signals to immune system, and there is a pro-inflammatory environment. And when you are long-term exposed to plasticizers, the long-term pro-inflammatory environment can cause a chronic inflammation, and this is what we don't want. So this is a specific example, and we studied plasticizers, phthalates, and there are many of the phthalates, but we study specific ones.
So you talk about long-term effects. So can I assume that when they are in the body, they stay there forever, or at least a very long time, or there is a way to get rid of them?
Yes, specifically the phthalates. The phthalates are something that maybe every of us is aware of. The softeners, they are easily metabolized. So they are metabolized and we can get rid of them easily. But we are constantly exposed to phthalates. That's a huge problem. But in terms of the chemicals, yes, we have a pretty strong detoxification system that can get rid of the chemicals pretty easily. In terms of microplastics, once they are in your, for example, circulation system, in your blood, or if they reach a specific organ, the fraction that is below 500 nanometers, quite a small fraction, could be degraded by macrophages. So the macrophages that usually degrade bacteria and viruses, but they were shown to degrade plastics and actually get rid of it. So the small fragments, the tiny fragments, can be actually degraded in our body.
Okay, so once a year, if someone goes on holidays and stays in the forest without eating any food that has been packaged in plastic, we can go back to a better state for the body. Is that what you're saying, or it's a lost cause?
That's a good question. Yes, I would do that.
would
not only for
recommend
to get rid of the microplastic, but it's good to
He's
stay
an
in nature
expert,
for a
you
while.
take notes.
Yeah.
Wow, this is a bit depressing, isn't it? So tell us something positive.
The positive things. Okay, so for example, we as a scientists are doing our best to really understand how harmful it is. And once we have enough information, we can, for example, suggest the mitigation strategies, like how to really get rid of the microplastics. We have to take into account that the microplastics are a consequence of much bigger problems. This is plastics. So microplastic is not, if you treat the microplastics problem, you will have a never-ending net that you will collect, every single piece of microplastics from the ocean. That's not the solution. Microplastic is a solution of the plastic waste. And now the question is not all about microplastics, it's about the plastics. We are producing a lot of plastics every single year. This is what we should care about. And how to improve the amount of plastic that is misplaced or wasted, because we recycle only 30%. The question is why we shouldn't recycle all of them. And the answer is actually what I said. Every single plastic is different. If I have two plastics, one would be black and one would be green, I would never get yellow. And I'm talking only about the color. If you melt the plastic, polypropylene, together, you will have mixture of chemicals, because different companies use different plasticizers, phthalates, bisphenols, adipates, whatever. Different antioxidants. You will never get the product that you want if you melt all the propylene together. That's a problem. So that's a problem. If I check the cups for yogurt in my superstore, every single of them is different. Why it is so? If there will be a regulation that would say the companies to to harmonize the packaging, every single yogurt cup would be the same. It would definitely help, recycling. It would actually support the circular economy. This is what we want, but it doesn't exist anything like that. Even the bottles, everything is different. So recycling sounds good. It actually very well works for a pure PET bottles. It works for them because PET bottles are not polluted. But if you see recycling sounds good, but in real it's very complicated. And I think this problem is in the hands of decision makers. That's how we can support that. And it's connected to microplastics directly.
So thanks to the bad news that we get from your research, we can push for change at the higher level, as you were saying, to reduce the types of plastics that we have in the environment.
Yes, you're correct, but it's very hard to say what is the strategy to push something to make some decisions.
Well, if you tell me there is plastics in my beer, I'm sorry, but I'm going to vote for change.
I'm glad that the beer is a hallmark of this problem. Maybe I will use it for
an example.
But yes. So I believe that if somebody would really harmonize just the packaging, that is like 30% of 35% of the plastic materials are single-use packaging. 35% of all plastic that we made is with single-use plastics packaging. So that's.
So back to bad news, because you talked about the impact on health, but what about on the environment? And maybe it's not exactly your field, but I'm assuming that you can also tell us about what it means when it's in the soil, for example, what it means for plants, for animals, because then it comes back to the food chain for us anyway.
That's a very good question. It depends on which animals or biota we are talking about. For example, in aquatic environment, microplastics do a lot of harmful things. Once you are ingested, it can cause inflammation and reduce the fitness of the fish and organism, and the population could be impacted. We can also sense the microplastic as another stressor that actually contribute to negative effects on organisms. Because nowadays, the organisms in the ocean, in the soil, in the forest are not stressed only on microplastics. But microplastics is another additional factor that actually reduce the health of the biota. They are chemical pollutions like pesticides. Yeah. They and stuff like that. So, for example, in fish, there is an interesting fact that the small fish, that very small fish, they instinctively hunt small particles as a food source. So once the fish, they actually eat the microplastics, and they do it. They feel full. They don't, eat more. Sometimes the microplastics can harm digestive tract, and the fish either die or actually is smaller than is needed and is more valuable to be eaten by predators. And this is how the whole, for example, herrings. It was shown that the herrings they really hunt the microplastic, they eat it, and then they are small, and the population can be reduced in addition to all other factors that the fish population can suffer. So it's definitely not very beneficial. In terms of soil, you mentioned.
Yes.
That's again, soil is a living piece of nature. There's a lot of microbiome that actually makes soil. And if we showed that the microplastics can do something with your microbiome, we wrote an excellent review that we collected all the evidences regarding the impacts of microplastics on microbiome. We published it and we showed that we should be worried about, that it is expected that it could also work in soil.
So as a vegetarian, I'm not safe by eating just vegetables?
By eating the vegetables, I think that you do your best for the environment if you are vegetarian, for other aspects than microplastics.
But I'm still poisoning myself.
If you eat soil, then yes. But if you eat vegetables, there are actually evidences that maybe the nanoplastics, that is another topic that might be under discussion, they might be transferred to plants.
So we're not sure. So
there is some ongoing research that use a very specific nanoplastics that have metals inside, very specific, unusual metals, and we can detect those metals in the plants. So it's expected that if we measure if the metals are there, the nanoplastics should be there too. But the nanoplastics is a different story.
Okay. I'm asking for a friend. Is there any animal that degrades better the microplastic and that we should eat more than the little fish that basically hunt them? What would you advise to eat to have less microplastics?
Okay, good question. So I'm not sure if I understood the question, but there is a lot of research that is about the microbiome transplantation, and we know that some microbiota can degrade PET. Some Japanese study investigated that there is microbiome that degraded PET. So maybe if this kind of bacteria would be transplanted, maybe it would help. But then I don't know.
But for example, between a small fish and beef, can we assume that the beef is going to have less microplastic? It's a different source. In case of fish, they are directly exposed through the environment, and the level is definitely much higher than the plastics that come from packaging. Okay, so who is ready for more bad news? I want to ask about nanoplastics now.
That's okay. Bad news.
Higher level.
I don't know. I don't want to stress everybody, but that's
too late.
I
think you've done it.
But that's how it is. But anyway, the nanoplastic that's a completely different story. The nanoplastics they are very hard to study. We know we have some specific approaches how to study nanoplastics, and we know that the degradation process of bigger plastic does not end up with microplastics. Microplastics, as I mentioned, is 5 millimeters and below. It's still kind of like piece of plastics. But nanoplastics are very tiny. We are talking about 1 billion of meter. It's unbelievably small. For example, somebody calculated that from 1 microplastics, the theoretical amount of nanoplastics is 10 power 14 particles. So it's 1 and 14 zeros. Nanoplastics from 1 microplastics. It's an enormous number. If the 1 nanoplastic would be 1 second, it would be 3.2 million years per second. So 1 microplastic can degrade so many nanoplastic as its number of seconds in 3.2 million years. It's actually the time when Lucy Australopithecus afarensis was walking in Africa as one of the first ancestors. So that's enormous. And nanoplastic is a different story. They are small, so they are different chemical, and they definitely have different chemical and biological properties than the original plastics. For many reasons, one of them that quantum physics can be applied there because it's nanoscale, and it can directly penetrate into your cells. So they can actually be transferred almost everywhere. And as I mentioned, there are specific approaches how to study them. So there is specific, the scientists, they put a specific metal, palladium, it's not very common metal, inside each microplastics, and they can confirm that once the rats are exposed in 24 hours, the microplastics, nanoplastics are everywhere, including the fetus and including placenta from both sides, from the fetus size and from the mother size, in addition to all other organs. So we know that they can cross biological barriers easily. What we don't know is actually almost everything. We don't know what is the load in the environment because it's very hard to study them. We are talking about nanoscales. We don't know what is the harmful effect. We know that once the experimental animals are exposed, in this case it was rats, the weight of the fetus was 7% lower, and the weight of the placenta was lower as well. So we know that it might have adverse effects. The question is, everything in toxicology is a question of dose, and we don't know nothing how we are exposed and if the concentration of micro and nanoplastics in our bodies can reach harmful effects. So again, it's a precaution principle that we are investigating all of it regarding plastic and nanoplastics, but we don't have very solid data how we are exposed, what is the level in the environment, what is the level of in the food and stuff like that. But nanoplastic, it's a new interesting topic that we should be aware of and we should study. And I don't want to nobody's scared. So,
but just going back to what you said at the beginning about nanoplastics, that the chemicals are different.
Yeah.
But they come from microplastics, right? I mean,
yes.
Nanoplastic is degraded microplastics. So from a set of chemicals, they degrade and they become different chemicals.
Yes, in terms of microplastics, they can degrade up to monomers, up to single chemicals that are microplastics consist of. Did I answer the question?
No, yes, you did, but I was just surprised at the chemical that they're different. Because I always assume if they are the building blocks of the microplastic, then you would find the same building blocks in the
very
nanoplastic.
Different, like very different. Chemically, the plastic are very different.
Okay, so that was indeed bad news talking about nanoplastics. I mean, uncertainty is in itself.
Yeah, that's
a problem.
That's an open question. We don't know much about nanoplastics in the environment in ourselves so far.
But please tell me that nobody is producing nanoplastics.
No,
okay.
that is not the case. Maybe you've heard about nanoparticles. That is very fancy materials. Is in many applications that we know that the nanoparticles we are using for paints, titanium oxide. That me personally, I received a nice gift that is socks with titanium. It's a silver, nano-silver, something that should reduce the number of bacteria living. I don't know what is it, but they are selling this. That nanoplastics is something that is better and better.
You mean particles?
What's that?
You mean nanoparticles?
Nanoparticles. That's a good note. Yeah. So, but nanoplastics, no, we don't produce nanoplastics. The nanoplastics is probably, I don't know any single application of nanoplastics, but nanoparticles, the metals, for example, yes, they are manufactured and they have their own specific applications.
But just to be clear, they have applications, but the risks are similar in the sense that they can get into the body and stay there.
Risk is actually the answer is yes and no. The nanoparticles, yes, they can penetrate your body because they are very small. So in with respect with the size, yes, they can do something. But the risk is always connected with a specific adverse health outcome, specific outcomes that with specific effects, let's say, and they are different. The metals definitely work different than the organics because the plastics are actually organics.
Okay, well, all of this is not very reassuring. So tell me, who is in charge of monitoring the situation, setting up regulations on the limits of what we should absorb, what should end up in the environment? Please tell me someone is in charge.
That's a tough question. Basically, okay, all the monitoring studies are actually are running by scientists because we are curious and we would like to know what is where. That's how it is. But I'm not sure if there is a strict European program for every single country that would monitor the presence of microplastics. Every single state have their own regulation and they do measure contaminants, for example, in drinking water, but also in the environment. But I'm not sure about microplastics. However, there are regulations in US, for example. It's called Microbeads Free Water Acts from 2015. And the only regulation is dealing with rinse of cosmetics. So what the regulation says is that in cosmetics that is rinse off and goes to waste, there should not be microplastic, that's it. For example, sunscreen that you don't rinse off is completely okay. But for shampoos, for other products, cosmetic products, that's the application of microplastic is banned. In European Union, we are close to that because European Environment, European Chemical Agency, European Chemical Agency, they propose, I think in 2018 or 19, the ban of microplastics in cosmetics. And I think in this year, the proposal should be finalized and then we will see what will happen.
So this sounds like good news, but is there any way to actually control that it's implemented? Yeah, of course, it will be implemented. I'm wrong. It's not about the cosmetics. It's about the manufacturing of microplastics and microplastics in primary microplastic in products. So it's not only cosmetics. It's actually, it would be a ban or regulation of every single plastics that we manufacture and put it in products. So yes, and I hope it will be implemented, of course, yeah. Implemented, sure, but I mean, who then... Do we have the technology to control that the shampoo or whatever then does not include microplastics when it goes on the market?
Okay, that's in terms of the cosmetics. For example, in shampoos, when I buy a shampoo, I look what is there, and you might be surprised how many cosmetic products actually contain microplastics. And well, we have some, of course, the detection system, the detection methodologies that we have are good for bigger plastics, but cosmetics is completely okay. Those plastics are bigger, and actually you can feel them. If you have a shampoo and the shampoo, you feel like a piece of sand with your fingers. It's actually microplastics.
I mean, it's not sand?
No, it's not. I wish it would be a sand, but it's not. It's not. Maybe if you put that's a good question. Like if you put there a sand, I would say the customers would not be they would not see the difference, but your base tube would probably get the difference because you would scratch it. That's why we use plastics, but that's the only difference.
It could be a marketing argument on the label to say with extra sand.
With extra sand, like 30% of the volume is a sand. So yeah, that's. But by the way, the microplastic, it's a kind of like a. It's a thing of commercial. Like the customers, I mean the producers, they say if there is a microplastics, it has a better property. But before microplastics, we use a shampoo and nobody really complain about the effectivity on this and that. So it's and they add their microplastic and they say we have new formula. The microplastic is there, but the microplastic is not necessary. It's not necessary. It does not do anything. I can tell.
Yeah, it doesn't sound like a good argument to sell a product anyway. I mean, maybe shampoo with nanoparticles, maybe people would be amazed, but plastics? Not sure. We're almost at the end of our little conversation there, so you have still a few minutes to think about your question for Ondřej. So be ready, because as I said before, no question, no wine. So, how are you going to save us? What's the next step in your research that will help have more data on the impact on health, for example? What will, how can you convince policymakers to address the issue of plastics a bit more aggressively? Tough question.
No.
I'm not thinking.
That's completely. That's a very relevant question. That's a very relevant question because we, as a scientist, we do our studies, we do our research, but it must end up in the policy, of course. So your question is very Brussels-like question, but I like it. It's very relevant. It's very relevant. It's very relevant. I have to say true. I don't know. I'm not a decision maker, but we would do our best to collect, the information, and to describe the situation, to describe the toxicity, to describe whatever is relevant for decision makers to actually take the action. And the decision makers, they need a lot of supporting information to make a decision. So what we can make is actually to do our job and do toxicological studies and to bring another piece of evidence that this and that is good or bad and should be banned or should be regulated. That's all we can do. That's my piece of contribution.
Right, so maybe I put too much pressure on your shoulders as one human being, but without talking about you specifically, what would be the biggest need for the next step in research in general for microplastics? What would be the biggest milestone?
That's a question that I can answer. It's described in vitro. It means that we use a cell cultures, a very separated cell culture in a Petri dishes that the macrophages can degrade the plastics. But for me, again, the microplastic is not a one particle. There are different kinds, different shapes, different sizes, different chemicals. So I would be really interested in how how our human macrophages are able to degrade the macrophages, because this is not described. So from this research, we can directly know if the macrophages is a real problem, if they are not degraded or hardly degraded, or it's a piece of cake for macrophages. And then we can say about the risk of hazard materials such as microplastics. So that's something that I am amazed and I will definitely be interested to do it.
That's quite a positive note to end a depressing topic.
Yeah. Okay.
In the sense that it's not just about measuring and then panicking, but also finding solutions to degrade it better and maybe understand which ones we should really worry about and which ones we can live with. I am at the end of my own questions. Ondřej, do you want to add something before I give the floor to the...
Maybe the real last comment, that the microplastics is a problem, but it's a consequence of a plastic problem. So if we solve the plastic problem, there will be no science talk about microplastics in the future.
But then what would you do?
Believe me, we as a humankind are experts on making or producing really bad chemicals. So I will never lose a job. That's what I know.
Oh, now we end on a bad note. All right. Well, thank you very much. So
my pleasure.
We have time for some questions from the audience. Then we might have some questions from the online audience, and then we might have some wine if you've been preparing your question properly. So who wants to go first?
Oh,
wow!
A lot of questions.
But they want to drink.
Okay.
So there you go. Hello, thank you for all the details. I remembered something that I got as a gift, and it was not plastic. It looked like plastic. It was a little bottle, not flexible, not soft, very thin, although full of water, containing half a liter. And keeping the water very cool in the fridge and keeping it cool even afterwards, once it was on the table. And it was very nice, and there was something written on it that I hadn't seen when I was offered that little gift. And it said, made exclusively of sugar cane. Sugar cane. It was not plastic. It looked like plastic. It was not plastic, and it was made out of sugar cane.
The
question is,
what is it?
You know about it, and how safe is that in comparison?
It's a PLA. It's a polylactic acid copolymer. It's a polymer made out of sugarcane, as you mentioned. It's one of the solution basically. Like we can replace a specific plastics with a bioplastics. In this, it means that the plastics are easily degradable and then come from the sugar-rich plants, specifically sugarcane. It's good for foodware. It's good for one-use forks, plastics, tables. I'm surprised that it's used for bottles, but it's I don't know what to say, quite common, but I found it quite often, and the foodware is made out of polylactic acid PLA. That's what it was. Most probably. By the way, the biopolymers, I would like to maybe highlight that it's a very good replacement of traditional plastics, but it's not suitable for construction materials. It's definitely not for the textile or automotive industry, because it would degrade. It would degrade quite easily. But for foodware, for one-use, single-use bottles, for forks, and stuff like that, it's perfect. Diapers, sometimes I'm made of it. That's a good.
Any other question? Yes.
Thank you for your question.
Good evening. You were talking about microplastic in placenta and in the rats that are not growing well, etc. Is there any study that is doing the link between microplastics in the blood, in the human blood, and infertility, and increasing the infertility?
That's a wonderful question. That's really one of the things that is actually happening, that is a decrease in fertility generally in males and females, in men and women's, in men and women in all over the globe. We think it's because of the chemical stress and the microplastics. That's a question. So the answer is actually the answer is I'm not sure, I don't know, but a recent study showed, or there is actually one single study that found microplastics in human blood, but the methodology that they used actually used a double spotted pyrolysis coupled with gas chromatography and mass spectroscopy. Make the long story short, they do not measure the particles in the blood, but they evaporate the blood and they measure the chemicals that our microplastics consist of. So they did not find any single particle in the blood, but they say that we have some chemicals that might be just chemicals, but these chemicals are part of the plastics, and they say we found the chemicals, so the plastic must be there. But that's not the case, and we need more studies to really find microplastics in the blood. So my answer is, actually, we don't know. We need to study that. We need more biomonitoring studies to understand what is the load, what we have in the blood. And we have a number of biobanks that have blood. We just need somebody who will look into it. And then there will be nice so-called association studies between the microplastics and the fertility. But make a long story short, you're right. I mean, many of the chemicals, they impact the reproduction. We know that. And the microplastics, they have them. So it's an excellent question. Thank you. But we don't know yet. We need more studies. That's how it is.
If I may follow up on that, so is there any hope that such study would be able to make the difference between the origin of the hazardous chemicals in the blood, for example, by saying, okay, this comes definitely from microplastic that have been ingested, or this comes from pesticides, or other kind of pollutants? Or there is no way to do that? What you see is chemicals and just chemicals?
Well, I am not sure if I get the question correctly, but the thing is that this methodology can't tell anything about the particles. So there are other techniques. They will be able to confirm the microplastics in the blood, but these specific techniques, no. You can't say if the chemicals that was detected are coming from microplastics or are generally part of the chemistry that we have in the blood. Because we all have many of the chemicals in the blood, including those that are parts of the microplastics. Did I answer the question?
Yes, you did. Yes,
okay, good.
Basically, it was about differentiating the origin of the chemicals, but
yeah,
you answered. You had a question, I think.
What was it?
Over there. Okay, good.
Yes, thank you so much for this very interesting talk, first of all. I was wondering if there's any, to your knowledge, any technology or research on creating technology that will extract microplastics from the environment or even from the human body.
Okay, it's a very good question because now we have. Okay, that's a good question. That's a question.
You mean when the person is alive?
Ooh, that's.
Otherwise, it can evaporate.
Well, that's the. Now the question is from the human or from the environment or both. Both generally, from the humans. Still, we are in the beginning, so we can't tell many information regarding the humans. That's what we know. We can measure them and found them in food and marine animals, for example. But in humans, that we still don't have any information regarding the environment. That's incredibly challenging. So there was some. Suggestion that some long net, a very fine mesh would be created that can collect not only the microplastic but also the plastic wave in the oceans. But can you imagine how big the nets should be? You know, maybe you are aware of the called plastic patches or plastic islands in the oceans. It's size of Europe. And the size don't imagine, you know, the solid piece of plastics in the middle of the ocean. It's like they call it plastic smoke or plastic dust. It's you know, when you swim in that part, you basically touch plastics, you know, every time, you know, you make your swim. So that's how it is. And in that specific region, the density of microplastic is high. The density of microplastics. So technologically, that's not feasible. That's not feasible at all to really collect the plastics from the ocean. And there is another thing, that the load of plastics into the ocean, mainly coming from Indonesia and China, which are the biggest plastic producers of polluters of the plastic of oceans with plastics, it's more than you would be able to collect. So that's I'm okay. It's too skeptical and too scary again, but technologically it's difficult, and there is no technology currently that would be able to do it in a high scale. You can do it in a local pond. That's feasible, but not in the oceans. That's impossible. The only solution, again and again, is a plastic in the beginning. Less plastic, more plastic recycled, unifying the covers, the packaging, and then less plastic in the waste. That's how. So, but no, actually, I'm sorry, but very good question. Thank you.
Again, to follow up on that, so if we talk about the ocean or rivers or whatever, microplastics don't float on the surface. They can go in 3 dimensions, I suppose. So a net that is small enough to catch microplastic would probably catch all the fish.
That's correct.
That's a problem.
That's correct. That's correct. It depends. Like some microplastics then go to the bottom, like PVC. It's very heavy. Some plastics that go to the bottom, they are biofold, so the small organisms are attached, and then they can swim again. And some of they are close to surface. And some plastics are something in between. So again, from the technological point of view, the net should be not only wide but also very deep, and you would collect almost every single fish there. Which there is another fact that is maybe important to mention, that currently the weight of plastics in the oceans is in the ratio 1:3 with the weight of the fish. In 2050, it is estimated that in the ocean, the weight of the plastics would be the same as the weight of all fish in the ocean.
I don't know what to say. It's awful.
I'm sorry, not good news for receiving.
Who has a question? Oh, more questions. Super.
Okay, thanks. Last week here in Brussels, we had the annual conference of the European Union on plastic converters. I'm not part of the industry.
Okay.
And then there were the speech by the president and also the president of Bioplastics. You can imagine that they were complaining too much rules and regulation from Brussels, and then plastics is seen always as evil and so on.
Plastic industry is enormous, yes.
Okay. My question is about the recycling of plastics, because as you say, there can be one of the solutions if we don't want to increment a lot how much plastic is around us. But when you recycle plastics, the material that you get is, in terms of quality, is the same quality from the material that you put in, and can create more microplastics, or?
Okay. The recycling. First of all, the plastic industry. The plastic industry is enormous. So currently in Europe, as you may know, there are more than 52,000 companies that somehow process the microplastics. So from the financial point of view, it's a huge industry. So the annual financial overturn is like 300 million euros a year, and it creates 1.2 million jobs. So it's something that we can't overlook. They have big lobby, and they are constantly and we are banning more and more chemicals, and they are actually developing more and more chemicals. But developing chemicals is extremely expensive because you have to prove that your chemicals is safe, and it costs a lot of money. So for example, I was talking about the phthalates. So the phthalates were banned, and company, I'm not sure if I can mention that, but why not? But basically, BASF they created a replacement of phthalates called DINCH, and they invested 2 million euros just to bring one single chemical on market. So I can imagine that they complain, because they invest a lot of money in plastics. In terms of quality, if you mix all the plastic, as I mentioned, the recycling process is very difficult because you can't really mix the same plastics together because you will never get the product that you want, the property of the product, dealing with plasticity, color, shape, and stuff like that. It's even more complicated because the recycling, in a plane, when I was on the way here to Brussels, I received a plastic bottle, and the plastic is PET. There is a lid from polypropylene, and there is a polyethylene foil. So there are three plastics together, and you have to separate it manually. So somebody must be paid to really take three parts together. Why is this important? Because when you melt, for example, if you melt 0.1% of PVC with polypropylene, the polypropylene will never polymer again. So it will come up from the machine as a soup. It will never create polymer again because PVC is full of chlorine, and chlorine has some specific, reactions with polypropylene, so it will not react again. So that's why you have to really separate the plastics. The other things is that many of the plastics are dirty from chemicals that you have no idea what was there. So that's also complicated the recycling. The quality it's currently much cheaper to really make new plastics from new polypropylene that costs 6 euro cents per kilo than to recycle and try to prepare something new. And the quality is lower. That's why. I'm not sure if I answer your questions.
The question was, I was wondering if with this recycling, we are going to create more microplastics.
Oh, okay. That's a question. I don't know. I will speculate. No, so I don't know. I'm not sure. No, I don't know.
But don't we take the risk of creating microplastic anytime we have plastics?
That's right. But the question if the microplastics would be more released from the plastics that are recycled than from the original plastics, right? So then I don't know.
Okay.
I can't comment on that.
There were 2 or 3 hands raised in the back. I see just 2 now.
Okay, thanks a lot. Well, a personal question. What brings you to the plastic topic? And second, you said that microplastics are everywhere. Do you have any idea where something that's immune to microplastic, person, thing, whatever?
Okay, the first question. I have to say that I have a friend that is a designer of plastics. So every single company, they have people that design the plastic for specific purposes. And so he's like a chemist person. And he was talking so much about plastics all the time. And now he used to be a CEO of a company in the middle of Europe. But now he's out of business. But he was talking about that much that I started to really trying to understand what is there and how all this plastic works, because suddenly you realize that it's not that simple as it looks like. That's really quite complicated chemistry inside. And the second one, if somebody is immune to microplastics,
rocks.
Actually yes. yes, it's possible, and I tell you why. In pharmaceuticals, some of the drugs, they have polymer. They are actually trapped in polymer spheres, and we know that the people that are constantly exposed to those polymers, small pieces that is the chemicals, the drug is inside, they have a faster detoxification mechanism. It's called accelerated particle clearance, and so more you exposed, your organisms can respond faster and more effectively. So at least this is what is believed will be the case of microplastics. But again, we are in the beginning of understanding like how it is behaved. But the human body is extremely good in detoxification. Like, if, for example, if you see the smokers, microplastic is a problem, but smoking, that's even worse. And there are many, even like worse chemicals that you can imagine. And the people, they can survive 60 years and more. So we have a very strong detoxification system.
Finally, some good news. There was a question over there, I think.
I hope I did not touch the smokers. That's not my intention.
But there are plastics in cigarettes, isn't it?
I'm not sure
okay,
about
that's for another event. Okay.
That's the last problem with cigarettes, the plastic. If there will be plastics, that's definitely not the problem of cigarettes. But anyway, that's a different topic. But thank you for a question. Excellent.
Yes, I had one question because you mentioned earlier the drinking water. And so obviously the municipalities have a responsibility in providing clean drinking water to their citizens, even if we're working with upstream work, trying to limit the amount of microplastics that end up in the system. And here we're already using like mechanical cleaning, chemical cleaning, biological cleaning. So I was wondering, what potential do you see for developing these methods further in limiting microplastics pollution in the drinking water?
That's a very good question, very relevant one. Filtration, probably, like more like probably very extreme kind of filtration, because you are filtering. Your filter must be in micrometer size. So that's the. I'm not a technology person, so that's what. But you said in the beginning that was very interesting, that you said that the producers should provide clean waters. That's the question, like, what is clean water? How is defined? It's defined from you have to look into regulations, and what is not in the regulation is approved, and the microplastic is not there. So you can see the microplastics inside the bottle, and nobody can complain because it's not part of regulation, right? So it's technically clean water. But dealing with the technology, it's wrong. I'm wrong, of course. I'm just present the worst case scenario or some. It's a theoretical question. But back from I'm not a technology person, but I would say that the extreme kind of filtration can rid of the microplastics. That's what I would guess, but I'm not sure. I don't know. But a very good question. Thank you.
Is there any other question in the room?
Oh, no question, or no time for question.
Well, there is a bit of time, I think, for question. So yeah, let's go ahead.
So thank you.
Okay.
Well, I've prepared lots of questions because I really like the wine, especially the Moravian one. But okay, out of the box, I get kind of depressed that the microplastics are everywhere, even in our food, our bodies, and everywhere. Are there microplastics in space, or are there microplastics on Moon?
Why are you planning
No,
to
that's
go?
That's a good question. That's a very good question. 100% yes, of course. I mean, yes, I'm serious. Of course, yes. I mean, again, like where is the human footprint? There must be microplastics. I can tell. So I'm sure that I see at least one photo of the footprint of human on the moon. So I'm guessing there must be at least one microplastic particle. and space, 100%. Yes, 100%.
So Mars as well, with all the robots that we sent.
I mean, at least I'm not sure what is the coating of the spacesuit made of, but I would guess that there will be at least a couple of microplastics. Microplastics are as well a virus from laundering. So microplastics are not only the spheres, but maybe I forgot to mention that, for example, during the laundry at home, like there is approximately 700,000 of viruses are produced during laundry, and there are also like microscale microparticles, microplastics. So back to your questions, if somebody was on the moon or Venus or Mars, microplastic will be there too.
But the radiations will kill you first, I think. So don't worry. So, were there any other question? Go ahead. There. Yeah.
I was on a toilet, so sorry if this was asked in the meantime, but there's been an increase in allergies lately, right? Like for crustaceans, for peanuts, gluten, lactose, whatever. So is there any data? Are there any studies that suggest that this could also be because of our increased use of plastics?
That's a very good question. Thank you. That's one of the things that might be studied. As I said, the microplastic is one thing, but the chemical inside the plastics is another thing. And in contrast to microplastics, the chemicals that have microplastic inside, they are well studied because the plastics are studied, and the plastics release all those chemicals, and we breathe them, we eat them. So they are studied, and so not the microplastics, but we know the chemicals. They can deregulate immunity, specifically, for example, T cells that are responsible for asthma, allergies, and actually the regulation of the immune system can lead to inflammatory environments that is a fundamental background of many diseases. So asthma, allergies is definitely, we know specific chemicals that are associated with specific diseases, with specific allergies. But generally, if the asthma or allergies are discussed, we are talking about the overall chemical stress, because we as a human are exposed to many chemicals, not only from plastics, but as I mentioned, for example, pesticides or specific chemicals that our textile has, for example, PFAS or stuff like that. So we are generally exposed to many chemicals, and together they may create something like they can increase the problem with allergies. That's what we believe is true. But many of the chemicals can be found in plastics and potentially in microplastics. So your question is very relevant, and actually I believe it will be studied in detail for sure.
But you couldn't really diagnose this very specifically because you couldn't trace specifically what kind of objects you have to avoid not to get in contact with
I know.
chemicals.
It's a question not of toxicology, but rather epidemiology. So how do people study this problem generally? So they basically collect all the information about the participants that are studied. For example, there are 1,000 people from one city, and they describe what they eat, what they do, where they work, how they travel, what they how they behave, if they smoke, drink, and stuff like that, about the diseases, and they measure the chemical of the blood. And they, on the other hand, they have a health determination of their health, and for those people that have asthma, based on a specific approaches in epidemiology, you can associate a specific stressor with a specific disease. But it's very technical. Basically. I mean that's
Can we ever imagine a doctor saying you are allergic to your water bottle?
I did not get your question. Can you repeat that?
Is it my understanding is that it's never going to be possible for a doctor to diagnose specifically that someone is allergic to a set of chemicals and then should not be exposed to plastic bottles.
Yeah, that's right. Yeah, okay. So we can, you're right. You're completely right. So based on very specific approaches, we can say that these chemicals are associated, for example, with asthma or allergies. We can tell that's possible. But the question, so what? You will not be at home because the chemicals are, everywhere at your home, because many of the stuff at home is not a wood. It's not. A glass, or it's plastics. In my home, 90% of the stuff is plastic, from the floor to wood, to tables, to computer,
That's a lot.
TV. That's my sofa. It's plastic. That's how it is. Yeah, that's a good question. What to do?
Convenient.
Yeah, that's not really a solution, but you can describe it.
But in a way, it's good so that we don't have to. I mean, if people start being allergic to specific object, then it becomes complicated to live in society. And
But the truth is, well, those chemicals that I know can support, the asthma is not okay. What you mentioned is that somebody can be allergic to specific chemicals. It doesn't work like that. But the chemicals can contribute to, for example, severity of asthma or allergies. For example, that you might have higher levels of the disease because you are exposed to the chemicals. So they contribute to severity, to higher levels of the disease. And so you have asthma, but you have much worse asthma if you live in the environment with specific chemicals. This is how it is. But you are not allergic to specific chemicals. You might have, but
and that's how you see I'm a political scientist. Because I don't understand these things.
Yeah, okay.
All right, thank you. More questions, please.
Hello, thanks a lot. I might sound like a plastic lobbyist for a bit, but I'm trying to reverse the solution to the problem. Do you think that there is a potential technological improvement that could make plastics not emit microplastics in a way? Let's say we improve collection to a great extent in those countries that are the biggest offenders in the ocean, and the rest of the plastics, they just don't get detached from the big plastic particle.
That's a very good question. Thank you for the question. Yes, it's possible, but how you do it? You have plastics, and if you put there an incredible number of antioxidants and UV stabilizers, then it will stay forever. But do we
want that?
That's a question. So you will definitely, there are approaches that can make plastics more stable, less degradable, be more how to say that, let's say, not that vulnerable for UV degradation and stuff like that. So it will be more less degradable. But do we really want that? So the answer is yes, there are approaches, but you made a plastic that is really hard to degrade and will stay forever. Even the normal plastics can stay hundreds of years in the environment. Yeah, somebody estimated that the plastic bags that we use them every single day. By the way, it's estimated that in the case of plastic bags, we use 60,000 plastic bags every 3 seconds. That's enormous. And we are, there's one single use, but they stay up to 1,000 years. You can still find pieces of these specific plastics in the environment after 1,000 years. So if we make, those plastics less degradable, less, producing the microplastics, that's not what we want, probably. But it's possible, yeah, technologically it's possible. And they are plastics that are hard to degrade for specific purposes, yeah.
More questions? I think you're thirsty. All right, okay. So if we're out of question, then maybe I have the last one.
Go ahead.
So you talked about mainly what we should do about limiting the amount of plastic in the environment as the most obvious solution. What can we do? We're not policymakers, we're not maybe scientists. What can we do as citizens to help with the problem? So you gave some hints already on what we should do, I guess using less plastics. But also what can we do to rid ourselves of or reduce our exposure to microplastics? Just as a conclusion, so what can we do so that we don't go home, or we don't get drunk sad, we get drunk happy?
Okay. Okay. I try to be as less pessimistic as I could. Okay, the first question. What we can do? We have to vote the proper parties that would have the right political pressure on the plastics problem, on the plastic industry, and how we treat the plastics in Europe. Maybe we can share the information about the problem of plastics and on the environment with the others, or with those people that are not so informed. That's what I feel is my mission. That I try to visit the high schools to really teach them about plastics and microplastics, and that's what we can do in our personal life, I would say. And to avoid microplastics, that's frankly speaking, that's hard. You know what, like, I don't know, like, how do people shop, but I shop in a supermarket, or my wife do it, and everything what I bring home is in plastics. I can tell 100%, maybe 200%, like really everything. And there are stores in my city when you can bring your own container and bring something to your home. But those shops are, you know, if I would be so strict and would like to avoid the packaging, I would spend probably 3 hours shopping in downtown. So I don't see a solution that I can do something in my personal life that will make a change, unfortunately. I don't do it because that's how we live, all of us, probably. But if something would happen on a European scale, because we are in Brussels, so we have to think it big, and something would say that the packaging would be unified, would have, you know, only certain type of plastics, it would help the recycle, and I, as a customer, would have no choice but to buy only, you know, the plastics that are approved for packaging and are only one type. So it's not maybe question of us as a customers on a, you know, daily based lives, but maybe the question may be higher. That's maybe I see it.
Thank you.
You're welcome.
Do we have time for one last? No.
Okay.
No, I had one, but it's. I mean, I forgot to ask it before, but why did you choose this field of research? What drove you to work on that?
Actually, I am environmental toxicology. So the microplastics and plastics is one field that I'm interested in, but basically we describe the toxicity of chemicals. And this is what I personally feel is good for the environment, because if we would collect enough evidences, some chemicals specific will be banned or restricted. And this is how we can make environment better, and this is what I want. So there are different kinds of people who like to take care of the environment, and you can collect waste, you can, you know, for example, live or use bioproducts and stuff like that. And I decided to become a toxicologist and to study the problems of chemicals that are, you know, becoming more and more problem. And we believe that if we would produce enough evidence of specific chemicals, the chemicals will be banned or restricted, and this is what we want. Or we can show that it's completely harmless and the benefit is more than the risk connected with the specific chemicals. That's also possible. But yes, the key motion is in my life is environment. That's why I do it.
That's a good one.
Good.
Thank you very much. So maybe it deserves some applause. Thank you. So we. Oh, you can keep uploading, it's fine. I think we can stay all night uploading. No. So we have reached the end of the event, so just 2 things before you go and enjoy a nice glass of wine. You can follow similar events on Facebook. What would be the handle? Yeah, okay, through the Facebook page of the organizers. You can find out information about future science cafes, and they're all great. I had a look on the Facebook page, they're all great, so I encourage you to follow up. Thank you very much, and now please, I release you, and you can talk about more positive things, or keep talking about microplastics with Ondřej. I think you stick around, right?
Yeah, I'm staying. So I'm really happy to meet you all.
It's going to be next to the wine, so in case you want to keep chatting with him, he's there. Thank you, everyone.